So my name is Christopher Marion. I'm a CAM specialist for SolidCAD here in Canada. I'm based out of Windsor, Ontario. So today what we're going to do is kind of get a little bit acclimated with some of PowerMill's automation, more notably on the macro programming language. So I would like to kind of start with just a few PowerPoint slides. I won't go too overboard with PowerPoint. So I'll kind of just start this off. Okay, so for those of you that are watching and maybe this is the first time you're ever going to see PowerMill, exactly what is PowerMill? Well, PowerMill, in my opinion, is Autodesk's elite CAM system for milling. So PowerMill gives us some high-end finishing and roughing strategies, really comprehensive library of those. It also gives us a whole slew of different types of toolpath editing, so we can really fine-tune and control our toolpaths. 2D milling, your standard drilling, feature detection, 3+2 machining, really good tools in there if you're doing anything above 3-axis. I really highly encourage you to look at dynamic machine control. Just maybe do a Google search for it. You'll get a good idea of what that does. 5-axis milling. So when we get into doing simultaneous, again, really good control in there. It's kind of what PowerMill's most known for. It does give us some mill turn capabilities. So that would be a mill that has some turning options. We do have other solutions to drive your multitasking turn centers. We will be doing a demonstration later on this afternoon at about 4:15. So if you want to see Mr. Christopher Crane show that off, I encourage you to go do that as well. Robotics. So if you were able to watch Aaron Kinnett's PowerMill robot demonstration yesterday, you really got a good feel of how PowerMill handles these industrial robots. And what we're here for today is to look at PowerMill automation. So really, why do we care about automation? It's really simple, actually. It saves us time. And that's really ultimately what we're looking for. We want to save as much time as we can when we're programming. The consistency, we want to really improve that consistency. Make sure that, every time we machine a part, maybe we always want to have the same type of flow to it. Increasing speed. So macros, really what it's doing is just reducing the amount of mouse button clicks. So if it takes me 10 clicks to do a function, maybe we can do that in 1 or 2 with a macro or a series of macros. And reduce redundancy. So if we're doing the same things over and over and over again, we want to reduce that. So we'll take a look at a couple of these scenarios today. So how does PowerMill automate? Well, we can create templates and store those templates and reuse those templates at any point in time. Again, macros is the kind of the common theme here. We can use macros. We can also tap into the macro language or the open source on PowerMill and create automated plugins and user menus as well. So what is a macro? Plain and simple, a macro is a text file that is made up of a bunch of commands that when we launch the macro, it's going to perform those series of commands in sequence. How do we write a macro file? In PowerMill, we can extract them manually by using a location in PowerMill where we can extract the commands. I'll go ahead and show you guys that. Or we can actually use a simple record function to record all of the mouse button clicks that I'm performing at that time. So that's about it for PowerPoint. I'm going to go ahead and just minimize that and show you the PowerMill interface. So let's go ahead and just import a file. If I was programming a part, that's the first thing I'm going to do. I'm just going to go ahead and open up this file explorer here, and I'm just going to use the drag and drop function and drag this file into PowerMill. Okay, so let's just lost some mouse control here. Okay, there we go. All right, there we go. Sorry about that. So there's the file that we're importing into PowerMill. Now, what we want to do is, if I'm a machinist and I'm going to start programming this part, there's a general workflow. We need to create a datum, define some stock, And then in PowerMill, what we're going to do is also define some safety planes. So looking up into the Home tab here up top, what we're going to do is kind of focus on this area here. This is kind of our toolpath setup section. So the very first thing we're going to do is define a datum, a block, and then some safety considerations. So creating a work plane, maybe what I'll do is select my entire part, create a datum or a work plane, how PowerMill calls it, on the bottom of my part. Then I'm going to rename that datum to maybe G54. And let's go ahead and activate it. Let's go ahead and define some stock. Let's draw that stock. What we're doing here is creating the minimum size required to machine this part, which in this case is 1.5 inches by 4 by 5/8. And then I'm going to go into just defining some safety planes. And I can even show those safety planes just for my own purposes. Okay, so you can see right there, we probably clicked, a dozen times or so. Now, if I'm programming 10, 12, 15 parts a day, that's a lot of redundant operations. So what we want to do is create perhaps a macro to reduce all of that redundancy. Okay, so let's go ahead, and I'm just going to start from the beginning again. So I'm going to close this file out, and I'm going to re-import that exact same file. Oops, let's just cancel that. Okay, so there's the exact same file. What I was mentioning before about extracting commands from PowerMill, if I open up my echo commands, we get to see kind of what's happening in the background. So if I were to do something like, let's go ahead and select the entire file. Select all. So the command for that would be edit model all select all. Okay. So we can actually copy and paste those commands and put them in a text document, or what we could do is use the easy button, if we call it that, and just simply record a macro. So maybe what I'll do is I'll jump back over to, in this case, my desktop. And on my desktop, I'm just going to call this setup. And it's going to automatically put the .mac extension. That's what PowerMill reads as a macro file. So at this point in time, anything I do in PowerMill is automatically captured into that text document. So for instance, if I was to still work on the same workflow as selecting the entire model, what I really avoid doing is selecting anything in here. So if I were to box select my model, it's actually going to capture the mouse pointer space in time to where I started that box selection to the end. So it's stuff like that you really want to avoid. So what I'll do instead is just right click, select all. So it's going to select the entire model or all of the models. I'm going to use that same function to create a work plane at the bottom. Expand, rename this to G54. Let's go ahead and activate it. Like so. Then maybe what I'll do is deselect the model, create my block, and let's go ahead and define those safety planes. And I'll even draw the rapid and the plunge surface. Just like that. And what I'll do is just stop recording. Like so. So let's go ahead and see what that file looks like. I'm going to minimize PowerMill and let's cancel that. Let's open up that file. So as you can see, there's a couple pick options here. This is the stuff that you really want to avoid. So really, I'm just going to remove that. Select those and bin them. So you can edit these macros by opening up in any type of text document creator. I prefer using Notepad++. Others like using maybe just standard Notepad or even WordPad. Here's another pick at the very end. I'm going to remove that as well. And let's kind of go ahead and see what we have here. So we've got all the commands that we selected one by one. So edit all sorry, edit model all, select all. That's the very first function that I showed you in the echo commands, kind of show you how PowerMill recorded that. And it's also got the option for renaming the work plane, and it's got all the options for setting my save areas. So one thing, what we really want to be cautious of is stuff where PowerMill hard codes, naming conventions or anything else like that. Because what if we wanted to run this macro on another part file, but maybe we want to change that work plane to say G56 or G57. So if we were to run this macro and it would always name it G54, we don't really have any control over how we want to name that work plane. So what we can do is start putting some logic in here, some really simple logic. Okay, I'm just going to put a few spaces, and the spaces don't matter because PowerMill's going to read, just like I mentioned in the PowerPoint, PowerMill's going to read these commands in sequence. So what I'm going to do is just establish a simple variable. So I'm going to type in the word string, follow with a space, and this variable could be really any name. I always usually like putting the V because I know it's a variable, and then maybe just for work plane. So VWP for work plane, then equals input, and I'm just going to tell myself or whoever's running this macro to enter the work plane name. So once we extract that variable, and we're using the string variable, which really represents that I can put a letter or any type of value in there. So a letter, a decimal, and a number. So we're going to rename this work plane to that variable. So VWP. And there's a couple other things we can do here as well, whereas when we made that work plane, it automatically assigns a numerical value. So PowerMill always, when we create something, either it's a toolpath, a boundary, always creates it as 1, 2, 3, 4, 5, 6, and so on. So what we could do here is basically tell PowerMill the last work plane that was created with this hashtag here, that last work plane that was created, I want to rename it to whatever you place into this input. These explorer functions, we really don't need those. So I'm going to go ahead and delete it. You'll kind of get acclimated to what you need and what you don't need. And also what I'm going to do is just change this line of code to replace the G54 with that VWP, which will automatically activate that work plane as well. So, 3 different modifications. We added 1 new line of code and removed a few others. Let's go ahead and save this. And I'm going to close that. Go back to PowerMill. Let's close that or delete everything. And let's re-import that file back in. There's that file. So now what I'll do is I'll run that macro. Well, how do we run a macro in PowerMill? Well, there's a few different ways. We can go to the Explorer at the very bottom, expand this, run the macro in that method, or we can actually run the macro here, or we can actually run a macro from a custom ribbon or tab that we create up top here. So for this instance, what I'm actually going to do is run a debugger. And what the debugger is, it's going to allow me to kind of step through the macro one item at a time or one line at a time so I can really see what's happening in the background. Okay, so I'm going to step through. We can see that it selects the model graphically. And then when it gets to this line, it should pop up a window to ask me my work plane name, which in this case, let's go G55. Green check. And what PowerMill is doing is holding on to that value for me. You notice that it renamed the work plane here to G55. The next line should activate that work plane since that's what it's doing here. And then we'll just carry on with the rest of the macro, which creates the block and then establishes the 2 safety planes. Okay, so that's 1 mouse button click that performed 10 or 12 mouse button clicks that we normally would do. And we could do this multiple times in a day. Okay, so let's go ahead and carry on with this, and let's just add on to this a bit. So again, I'm just going to delete this and kind of start from fresh once again. And something that we've been doing at SolidCAD is trying to create a heavier portion of automation onto this subject matter. So for setup, if I'm doing part setup, I really want to kind of eliminate maybe as many errors as possible, because that's one situation where there could be an error with the work plane name. But what about block sizes? So, and that in this case, if I create a block, it's going to create that shrink fit block around my part. Well, what if I have, a print where this part has a certain size billet that I need to machine from? So 4 1/4 by 2 inches by 1 inch deep. And it also is telling me that I need to have at least, in this case, 1/8 of an inch set into my part in my vise. So let's go ahead and minimize that print. And this I'm going to do is I'm going to import the part file as well as a vise or a fixture. Okay, so there's the part in my vise. Now, if I were to run that same macro that we just wrote, what would happen is it would try to create the block around both my vise and my part. We really only want to machine the part, not the vise, obviously. So what we're going to do is go up into a custom ribbon that I created. And the very first macro we're going to run is this part setup macro. Okay, and what we've done here is there's a series of decision makings. So when we create a datum, we can create a datum from the standard block points, or we can create a datum from maybe portions of the model, maybe a hole, or maybe the bottom of a pocket. So we're just going to hit OK, and we have both options. So in this case, I'm just going to click the first one and carry on. So since we've got multiple models in here, I really only want to create the block around the model that we're machining. So I'm going to go ahead and select this model here. So the very first question that pops up is how much stock is on the bottom of the model? Well, there could be many factors here where errors could pop up. One thing could be if I hit a letter on an accident. Well, we're going to get a warning basically telling us that the value needs to be numerical. And it's going to pop me right back to where we just were. So maybe I put in 0.125 because that's what the print says. And green check, the value must be negative. Okay, so it's helping us along. So let's put in a negative value here, and then it's going to carry on to the next question, which is the overall block height. So since if we look at the prints, the overall block height is 1 inch. Let's type in 1 inch and green check, and it's going to continue on. The overall block X dimension, the part said 2 inches. So let's go ahead and put 2 inches in there. And the overall block length in the Y-axis, according to our work plane at this point in time, is 4 1/4. Okay, so the macro is going to pause, and then it's going to ask us to pick where we want to put our datum. So I'm going to put it in this top left-hand corner of my part and resume. And then it's the same function we just did in the other macro where we're just going to enter the datum name. So G54. Do I want to rotate the datum? Well, maybe I want the X aligned to the length of my vise jaw. So in this case, I'm going to hit yes, put a rotation value of 90 degrees. And there we go. And it's just going to give us a little message saying, is this correct? If we wanted to back out, we could. So in this case, it is correct. I do not want to rotate again. Do I want to shift the datum? Well, maybe I made a mistake and I want the datum actually on this corner. So let's go ahead and hit yes. I'm going to shift it in the Y-axis. Minus 2 inches. Like so. So we'll just keep carrying on. And then we're met with, how much or where's our rapid plane? So in this case, maybe 1 inch. And let's go 1/2 an inch for our plunge. And then what we could do is select the machine that this part's going on. So this is going to set up our post processor. It's also going to set up where all our NC code goes to. So maybe we want to go to a set folder. So all this stuff is happening behind the scenes. So let's put this on our Mazak. And really, you're not going to see anything happen, but it kind of sets everything up with regards to preferences. So it's setting up our post file here. Okay, so that's one way that we can automate, especially on this setup. There's also another way we can automate where we go into programming automation. So what we're going to do is we're going to just stop here real quick. I'm just going to see if there are any questions. So
actually, there are a few. They can probably wait till the end, Chris, if you want.
Okay, nothing related to what I just showed. So we wait to the end. Okay, perfect. Thank you. Okay. So let's go ahead. I'm just going to go ahead and close all this. And let's go ahead and look at a different file, different part. So I'm going to jump over to, let's go to the mold part here, and I'm going to bring in both of these files. Kind of the same situation that we just looked at, where we've got a mold component, and then we also have, like a fixture plate of some sort. So before I do any type of programming, what I'm going to do is I'm just going to go ahead and save this project. I'm going to save it onto my desktop as mold. Okay, so I saved that project, and maybe also what I might want to do before I do any type of programming is I might want to start capping some stuff. There's no automation to this. It's just kind of showing you some of the functionality. So I'm going to go into my levels and sets, just turn off my fixture. I'm just going to close that off real quick, and I'm going to bring some of this stuff over to my modeling. So let's go select all this, surface modeling. Okay, so it's just opening up PowerMill modeling. Okay, just kind of showing the general workflow maybe as a programmer. Let's go into levels and views. And let's turn on the edges. Okay, Control T. So what I'm doing here is just creating some cap surfaces. Apply cap over these holes, these openings, because I don't want my tools to go in here. Okay, and also what I might do is just cap this opening. Apply. I have to create some curves here, so I'm going to go ahead and create a curve on this edge. Fast forward that around, save it. Apply that, and I'm going to do the same thing on this last opening. And apply. All right, and lastly, what I might do is just cancel that. I don't want a surface there. I'm going to select this. Just going to mask these surfaces for a second, because what I am going to do is just create an extension around the outside of my block. So I'm going to create a curve like so. And we're going to go into the surface functionality, create an extension. Let's go, it needs to be an angle, 90 degrees. Let's go 1/4 inch. Let's just do a quick preview. Looks good. Apply that. And I'm going to bring all this stuff back over to PowerMill. Just quickly creating some surfaces that I might need for machining. Okay. And let's go ahead and bring our fixture back in. All right. So once I've gone through and I've capped some holes, put some extension surfaces on. Are they necessary? The extension surfaces might not be necessary, but since I'm roughing, I might not want my tool to come outside the block. And I don't want my tool to go in these openings in the roughing process. Maybe want to cap these and we'll get them when it comes back from heat shrink. We'll get these maybe in semi-finish and finishing. All right, so what we're going to do is just go ahead, back up to my automation. Let's run that part setup once again, just to show you that it's not going to work just on that simple one block I showed you earlier, or the one part. So stock block points, we want to create the block around my mold. There's 0 stock on the bottom of my part, and 6.5 inches on top. I know that the block is 17. and maybe there's a couple hundred thousandths or 100 thousandths per side on each side. So let's go 11.2 and 17.2. Same situation. I want to create my datum. I'm going to put on the bottom center of my part, like so. Let's call this G55. I do not want to rotate, and I do not want to shift this time, but I do want to put my rapid plane an inch over the block, and I want to put a plunge plane maybe 1/4 inch over the top of the block as well. And let's go ahead and decide which machine. Maybe this is going on my Makino this time. Okay, so I did that real time. You can see how quick that is. Now what we want to do is drive a roughing process off of this part. Now, what does this mean? Well, I'm going to just jump back into the Home tab real quick. And if I go into the toolpath strategy selector, kind of go down the left-hand side here, in this folder, I've got 4 strategies that I use for roughing all the time. At the very beginning in my PowerPoint, I explained that you can save templates. This is basically what we've done. So if I go ahead and click on this 3-inch rough and hit OK, just going to bring this in. There's no automation here. I'm just bringing in this toolpath strategy that I saved. Okay, so there's my tool. There's my toolpath. And really what this template has done is it saved the offset style. Okay, it saved the direction of cut, it saved tolerance, it saved toolpath, it saved anything in this file that I want to save as my template. So I want to use it moving forward. It also saves the tool. But one thing you're going to notice that, again, just like I mentioned before, PowerMill creates everything numerically. So toolpath 1 followed by tool number 1. So let's go ahead and I'm just going to close that or delete that toolpath. Delete the toolpath, delete the tool. And what we're going to do is run this macro, which will import each template one at a time. And it will also ask me to create a stock model. And if you're unaware what a stock model is, think of this as a representation as to where we are in time on our stock. So it's a stock management tool. It's going to show me where we're at in time. It's also going to allow me to take the next toolpath and refer to that point in time. And it's also going to allow me to review where the stock lies at that point in time. So let's go ahead and run this roughing automation. And the very first thing it's going to do is ask me the name of my stock model. So I'm just going to simply call it stock. And enter the stock model tolerance. How accurate do I want PowerMill to read off the stock model? I'm going to put 5 thousandths. The stock model step over. This really is just, think of it as wireframe. It's how far these wires are from each other. And the stock model rest thickness, since I'm leaving 50 thousandths on this part for roughing, I really only care about maybe stock more than 75 thousandths. Just show me where that stock lies. Okay, so as this is calculating, it's defining the stock model. I'm just going to expand this real quick. You can see all the values that we placed in are here. It's creating the stock. It's creating the first tool path. It's also importing the tools. It's naming everything as well. So it's named the, yes, Louis.
Yeah, I just want to tell you we're at the 30-minute mark, but you can keep going for another 5 minutes. No problem.
Actually, this is going to calculate for, maybe a minute or two. Is there a simple question I can jump on?
We do have a couple of questions here, Chris. One of them is, it says, interesting material. What language is the PowerMill macro based off?
Yeah, it's a good question. There's really not a standard macro language in PowerMill. Think of it as, it's almost like a hybrid language. PowerMill is its own unique language, but it also runs off the same properties of like Visual Basic or C++. So really, if you understand a combination of those languages, this will make total sense to you.
Perfect. One of the other questions is there any documentation that people can refer to build their skills?
Yeah, absolutely. So the nice thing about PowerMill is the fact that they've actually placed in the PowerMill interface. I'll have to show you once it's actually done calculating, but there is a macro programming guide in here. There's also a few other guides, but the PowerMill macro programming guide is probably the most useful one that I found. It's probably 150 or so pages. Starts at the very basics at the very top, but it does progress rather quickly. So I suggest starting slow, get acclimated with it, read through it, because again, it goes from 0 to 60 rather quick, but it's definitely readable, and it's a very good assist as well. And there's also in PowerMill, there's a location to grab all of the PowerMill parameters as well. So if you're looking for a particular parameter in PowerMill, maybe something along the lines of a certain toolpath thickness, you can run through this reference and find that exact parameter that you're looking for.
Excellent. We have another one. It's a thank you for an awesome presentation. Does it matter what version of PowerMill you're using?
Absolutely not. So PowerMill, I know the functionality in PowerMill for recording macros, it's in all variants. So whether you have standard, well, there's premium and ultimate, but those have kind of been bundled to ultimate now. But you do have it. You can do it in standard or in ultimate. Doesn't matter. You can also, for those of you that do have PowerMill, if you go to the start menu and you look at, let's go to PowerMill 2021, there's this new PowerMill viewer, which allows you to basically run PowerMill without a license. So you could use that variant of PowerMill as well to construct macros. You don't have the record function, but you do have the function of looking at all the background commands with your echo commands, copying and pasting them and building those macros. So you do have that option.
That's very insightful. Thank you. Does PowerMill have an adaptive roughing toolpath?
Yeah, there's actually two. So the nice thing is about the collaboration between developers on the Autodesk side is the fact that Delcam has their own patented adaptive roughing. That would be Vortex, but there's also, if I just kind of pop open here real quick, there's also the one that came from HSM or Fusion, which is the other adaptive rougher, which I kind of find I kind of like a little bit. Personally, I like the HSM algorithm better. I just feel like it's a little bit more smoother, but they're both good. They're both reliable. So if you go to Vortex, Vortex would be PowerMill's name for adaptive. There's two different styles, from model and from stock. So the HSM or Fusion, and then Delcam's. So one last thing before we get into some other questions, I just kind of want to continue on with this just slightly a little bit longer, just to kind of show you what I meant by stock model. So let's kind of just shut off the model here real quick, and we can kind of see all this purple stuff. This is actually the stock that's remaining or left over. So the nice thing about the stock model is we can kind of start at this point in time after our first rougher, the 3-inch rougher. This kind of shows me where all the stock lies on my part over that value, that threshold of 75 thousandths. And we can kind of go back to the end in time, which this case is the 1/2-inch tool. And we can kind of see that, there's a couple holes we didn't drill out, and there's a couple spots here where there's excess amount of stock, but maybe this is okay. We can send this to heat treat, and then we'll worry about this when it comes back. Lastly, what we can also do is, let me just turn on that model real quick, is we could automate some kind of the setup sheet process here as well. So I'm going to run setup sheet. Maybe this is the image that I want on my setup sheet, something like this. Resume. And it's kind of doing everything behind the scenes again. And then it's going to pop open our setup sheet with, all of our values here, whatever we decide to put on our setup sheet. And it also allows us to customize what we want to see on the programming side. So we can see all of our toolpaths. You can see the last toolpath that I just created, which, obviously is, we can delete that one, but it gives me the tool name, it gives me the tool number, it gives me all that pertinent information. So this is also something that we can help you with if you guys are looking for, customized setup sheets. and included, it's within a macro as well. Kind of does everything for us. So with that being said, I will stop my part of the presentation here, and we'll go back to you, Chris. If you have any other questions, we can start answering. If hopefully there's some other questions.
Yeah, there are a few more. I just want to let you know, 56 people were watching this presentation. That's amazing.
Beautiful.
Yeah.
Good.
Yeah.
Awesome. Hope 56 people got something out of this. So, Mr. Crane, any other questions?
There is. The comment is, it's interesting stuff, guys. Could you expand a little bit on the drilling automation?
Yeah, there's a lot of things you can do with drilling. Out of the box, PowerMill gives you a nice automation tool in drilling, and we call these drilling methods. So I don't have time to show an example of drilling methods, but maybe we'll save this for another presentation at some point in time. We can go on to drilling automation. And drilling methods is a really simple way that you can produce a methodology on some holes. So for instance, I'll just pick on this plate here. These are FCS locations. You know, we might have 5 or 6 processes to get this hole into this plate. Well, drilling method is really, that's what it is. We set up a process on how we want to drill those FCS locations. Maybe a spot drill, number 1. Maybe the next one would be to drill with a certain size drill, then tap, and then mill, and then chamfer. So we can set that up in a drilling automation, a drilling method. We can also create just a standard macro to kind of attack that same method. And lastly, again, hopefully I have it loaded in. But on the plugin side, there's a few different plugins in here, but one that was developed by Michael Grenier at Autodesk is the drilling automation. And this one is another way that we can automate holes, and we can set up templates. We can actually look at methods as well. This is also another great tool. So if you're looking at, if you want more information on this, if you're a PowerMill user and you want to see this drilling automation or you want to have access to it, let me know, and I can fire it over to you.
Yeah, and on that comment, I think if there's anything that you guys saw that was interesting to you, please do reach out to the team at SolidCAD, and we can take a deeper look into the things you guys are trying to do. There's a great presentation, Chris. Lots of functionality that you showed there. The macro language kind of helps everybody get to the next level of automation. So, and I mean,
absolutely,
I think that's where everybody's.
That's what we're striving for, right? So, you strive to reduce your mouse button clicks and increase your workflow. That's for sure. So,
all right, good stuff. Good stuff. So if we missed any questions, we can answer those offline, or you can write directly to Chris at SolidCAD. So that concludes our presentation on automating PowerMill. Thank you very much, Chris Marion from SolidCAD and Chris Crane from Autodesk.
Now, yeah, thanks everyone.
Yeah. Now, please take some time now to visit the exhibitors at the virtual expo between 3 and 3:30. And afterwards, I hope you can join us for the cool presentation on generative design, and that'll be followed by a presentation on FeatureCAM for multitasking centers. So thank you, everybody.